Okay, so here we have an inequality. Notice I went ahead and graphed y equals x plus 3, y-intercept at 3, up 1 over 1, up 1 over 1, etc. We can look at these points. We want to see which points will make this a true statement. So I'm going to put this first one in. Is -1 bigger than -1? No, it's not. Okay, so that is not on our line. So I need to take that off. And so to represent, in fact, none of these points will actually be on this line when we go to plug them in. So instead of drawing a solid line, we're going to do a dotted line. So we're going to make this dotted in because none of the points on the line make the inequality true. But what does make it true? Well, let's look back through these points that I've given you. And what you want to do is you want to test these points and see which one are true. I'll give you a few minutes to do that. All right, so the ones that do in fact work, you'll see here where I have put in 1 and 5 right here. And so then it does in fact work. 5 is larger than 4, and so I put a dot at 1, 5. And so you'll notice that when I went to plot all the points that did work, notice that they are above again. So again, we're going to graph to show all the points that will make this inequality true are all the points in this that's above the line. Every point in this here would make the inequality true. Okay, if we look at letter A, if I put -4 and -1 in here, let's see if it makes a true statement. Is -1 greater or equal to -1? Well, yes, so that is a true statement, and all of these will be. So if all of these points make the inequality true, we're going to use a solid line. Notice the little equals. And now we're going to see which points are going to make our inequality true from the list below that I've provided. So we're going to plot the points that do in fact work, and we'll see which region gets shaded. Okay, so if you look at the ones that work, it's the region above. So we want to represent all the points that will work. So we would shade above our line. Got across there, didn't I? So every single point within the shaded region make the inequality true. And it would be impossible to list them all. So that's why we shade them. Even fractions are involved. Like, for example, 1 and 5.5 would work. And 1 and 5.6 would work. So even fractional parts, it would be impossible to list them all. There would be an infinite number of points within this region. And this is the only way that we can graph the solution is by graphing the inequality, because it's impossible to list all the solutions. So if it says y is greater with no equal sign, it's a dotted line because the points on the line don't make it true. And we're going to shade above. If y is greater or equal, it's a solid line, and you shade above. Okay, letter C. Again, it's the same, basically the same line. Let's see if the points on the line will make it true. So if we put in our x and our y here, our y-intercept is at 3. I'm going to go ahead and sketch where the graph would be, the boundary line. Slope is 1 over 1, up 1 over 1. We can draw our line. We need to see if these points make it true. So if we were to put in -1 greater or equal to -4 plus 3, is that true? Well, yeah. So -1 is less than or equal to -1. So that's a true statement. So we can go ahead and plot that point. It's going to be on our line here. Let's see if I can get that in there. Oh, -1, excuse me. -4, -1 down here. So you want to test again to see which points are going to make this true. All of these should, if you were to put each one of them in there, and then try the ones on the list and see which region ends up making it true. Is it above or below? So I plotted a few of them, but basically all the points below the line make it true. Make this inequality up here at the top true. Okay, so when I put these two in, It didn't work. So the points on the line are not going to make a true statement. -1 is not less than -1. So the points on the actual line do not make it true. So we're going to dot this in. So at negative, so we have -4, -1. So which points do make it true? None of these do. So we dot that in. We looked at the list below. Which ones are going to make it true? We're going to plot those points and then see which region above or below gets shaded. So it looks like these down here are going to make it all true. Notice where the points, I only plotted a few of them, but the points below the line are going to make it true. So to represent every single point, we would shade below this line. All the points in the shaded region make it true. So here's what we notice. Now you're going to write a little summary about how we do this. How do we represent the solution to an inequality? Okay, check your answers so far. You may need to pause this video. Okay, sometimes we can have two inequalities, and what we're looking for, this is called a system of inequalities. So if you would change that word there, I should say inequalities. What we're looking for when we did equations, we're looking for the intersection. Here, if we're doing inequalities, we're looking for the overlap of the shaded region. So here I have graphed it for you already. And then if you would answer A through F, and the main one that we're looking for is which point satisfies both inequalities. Let's highlight that piece in red. All right. So the part that we're really interested in is the overlap, which is, I think you can see it where the lines, where the shaded part I attempted to, in black and white, overlap. This region here, it's area 2 there, is the answer that will satisfy both inequalities, and that's what we're after. All right, let's do a couple down here below. All right, step 1 is to graph the boundary. So our y-intercept is at -5. Our slope is 6/5. So from this point, I'm going to go up 6, 1, 2, 3, 4, 5, 6, and right 5, 1, 2, 3, right here. And then I can draw a line. And we need to decide if it's dotted or solid. We look to see it has an equal sign underneath, so it is a solid line. Close. Step 3 is to shade. It says that y is less than. If you look at the summaries that you wrote down, y is less than or equal to gets shaded below. Now, if you don't memorize that, you will have to test a point. You can pick an x and y point and see if it satisfies, like we did it at the very beginning. See if it satisfies and see which region all the points end up working. All right, let's look at number 2, which is a system. So step 1, again, we're going to graph the. So number 2, we start at -2. Our slope is 1/2, so we're going to go up 1, right 2. Draw our line. We need to decide if it's dotted or solid. This one is solid. No equal sign. And then we want to shade. Does it get shaded below or above? It says y is greater, so this one's going to get shaded above. Now I'm doing this in color, so I'm going to be able to see the overlap. If you are not, you might want to do lines sort of vertically, I guess, and then do, for the second one, do lines going the opposite direction. Okay, so I'm going to try to mirror that, because we're really after the overlap. If you do a standardized test, they will only graph the overlap section. All right, so there's my pink one sort of there. And now if I do the second one, we have a y-intercept at 1. Do this in a different color for you. And down 1 to the right 1. Dotted or solid. Well, it's going to be dotted in as well, because there's no equals sign there. There we go. I probably need to extend that one out so I can get all of it. And we have to decide if we're going to shade below or above. And this one is y is less than, so I'm going to shade below this blue dotted line. And again, where the overlap happens is really what I'm interested in. And so right in this region is our solutions.